So this is an FRQ 2010 AB content number 6. The given information is solutions to the differential equation dy over dx is equal to xy to the third. Also satisfy the second derivative of y to the third times 1 plus 3x squared times y squared. Let y is equal to f of x be a particular solution to the differential equation dy over dx, which is equal to xy to the third with f of 1 is equal to 2. So part A says write an equation for the line tangent to the graph of f of x at x is equal to 1. So let's look at what we need for the equation of the tangent line. We need the slope and a point that has an x and a y value. So the slope is given to us, which is dy over dx equal to x times y to the third, and we also have f of 1 is equal to 2, which can be written in a point form as 1, which is x, comma 2, which is a y. So let's plug it into the slope equation, which is dy over dx at x is equal to 2 at x is equal to 1, which is the point 1 comma 2, and it's going to equal to, so we plug it in 1 into the x times the y value, and y is cubed, which is going to equal to 8. And this is our slope. Now that we found our slope, let's plug it into the equation. So y minus y1, which is a 2, equal to the slope, which is an 8, times x minus x1, which is a 1. And let's make it equal to y equal to. Y is equal to 8 times x minus 1 plus 2. And this is the equation of the tangent line at x is equal to 1. So let's move on to part B. Part B says use the tangent line equation from part A to approximate f of 1.1, given that f of x is greater than 0 for x is greater than 1 and less than 1.1. Is the approximation for f of 1.1 greater than or less than f 1.1? Explain your reasoning. So let's deal with the first part. Use the tangent line equation from part A to approximate f of 1.1. So the equation that we've got was y is equal to 8 times x minus 1 plus 2. And we know that y is the same as f of x. And we need to approximate f of 1.1. So we just plug it into the x. So 8 times 1.1 minus 1, all in parentheses, and plus 2. So 1.1 minus 1 is 0.1, and times 8 is going to be 0.8. So f of 1.1 is equal to 0.8 plus 2, which is equal to 2.8. And that's our approximation for f of 1.1. The next part of letter A is asking us if the approximation for f of 1.1 greater than or less than the f of 1.1 itself, and then it asks to explain your reasoning. So for this we're going to use the second derivative to find out the concavity of the function. Since the sign is positive, and we see that in this parentheses everything is going to be positive, because even if a negative number is the value of the x squared, it's going to be always positive. And also it is known that f of x is greater than 0 from 1 to 1.1, which is the interval we're looking at, which is the same as y is always greater than 0, so this y will always be positive. So that tells us that our graph is going to be concave up, which means that the tangent line lies below the graph, which tells us that our approximation of f of 1.1, which is 2.8, is actually less than the actual value of f of 1.1. So our written explanation would be that since the second derivative is greater than 0, f of x is concave up which means that the tangent line is below the curve, and our approximation is less than the actual value. Now let's look at the last part C. Find the particular solution y is equal to f of x with initial condition of f of 1 equal to 2. So for this we're going to use the first derivative and do integration by parts to find the solution to f of x. So let's set it up. So we're separating y with dy and x with dx. So what we can do is divide by y to the third both sides, and we will get 1 over y to the third dy over dx equal to x. Now what we can do to bring the dx to this side is multiply by dx, and this is what we're gonna get. So it will be 1 over y to the third dy equal to x dx. Now we can integrate. So the integral of y over y to the third dy equal to the integral of x dx. So 1 over y to the third can be rewritten as y to the negative 3 dy. It will still be equal to the integral of x dx. And then y to the third, the integral of y to the negative third is going to be y to the negative 2.
No.
And a negative up front to make it positive. And divided by 2, so it will cancel out. And then the integral of x is going to be 1/2 x squared, and we add c. So now we can plug in the initial condition, which is f of 1 is equal to 2, or the point 1 comma 2, and this will be to find c, the value of c. So we plug in 1 for x and 2 for y, so it's going to be negative 2 to the negative second power over 2, which is equal to 1/2 times 1 squared plus c. So this could be brought down, and we'll have negative 1 over 2 squared is going to be 4 times 2 is 8, equal to 1/2 times 1 squared is going to be 1/2 plus c. Now we can subtract 1/2 from negative 1/8, negative 1/8, subtract 1/2, which is really 4/8, is equal to c. So this is going to be negative 5/8 is equal to C. Now we can plug it into the equation that we've got to get the original equation. So this is where we're going to plug in C and solve for y later. So plugging in C, we get negative 1/2 y to the negative second power is equal to 1/2 x squared minus 5/8. And what we can do to get rid of this 2 and this 2, also we can multiply everything by 2. And let's see what we get. So negative 1/2 times 2 is going to be just negative 1. And to make it easier, we're going to multiply by negative 2. So y is to the negative second power is equal to this multiplied by negative 2 is going to be negative x squared, and this multiplied by negative 2 is going to be positive 5/4. So y to the negative second power is the same as 1 over y squared, and if we do the reciprocal of that, we're going to have y squared is equal to 1 over negative x squared plus 5/4. So now, to leave the y alone, we're going to take the square root, which is, so this is going to be y is equal to plus or minus square root of 1 over x squared, negative x squared, plus 5/4. Now we need to find out if it's a positive or a negative. So our initial condition says that when x is equal to 1, y is equal to 2. So y has got to be positive, and this can only happen with the positive in front of the square root. So our final equation is going to be y is equal to positive square root of 1 over negative x squared plus 5/4.